So can you all hear me just fine?
Oh, yeah.
Okay, okay, good. So let's begin. And so now we want to talk about the relationship between Stackleberg and Cournot. And so the Cornell model is the basic duopoly or oligopoly model that we've been talking about that involves a Nash equilibrium where we construct two reaction functions and then find the solution of those reaction functions together, the simultaneous equations type solution. And so here's Cournot. And just for some basic data, we start out initially with a demand function, and it's going to look basically like this. It's going to be a linear demand function. The important thing to bear in mind is that the total quantity of output is going to be the sum of output from, in this case, just the two firms. You can do Cournot with 3 or 4 or 5 firms. It's no problem. It's just that you have to, expand the list here of how many firms contribute to the industry output. And hold on, wait a minute. There. Okay. And so that ends up being the beginning for the Cournot problem. And just to be a little bit more explicit, I'll go ahead and substitute in okay. My dog's growling. Okay. So and it ends up being easier if we go ahead and we continue and expand this expression, just so we can see where everything comes in. Okay, so that's a pretty good place to start. And then in terms of calculating or constructing the reaction functions for each of the firms, the reaction functions for the firms are just the basic solution to the profit maximization problem, which means they rely on this condition that when firms are maximizing profit, their marginal revenue is equal to their marginal cost. So we'll pick one firm and do an example. Okay. So here we want to maximize the profit of firm 1 considering the information above. So I'll call that profit of firm 1, where that's going to be equal to the revenue of firm 1 minus, and I'll go ahead and put total revenue and total cost just to be explicit. Okay. And so the reason we're focusing on total revenue at this point is only because we want to get an expression for the marginal revenue of firm 1. And we want to remember that the marginal revenue for firm 1 is going to be equal to the change in the total revenue of firm 1 divided by the change in the output for firm 1. So we can again employ marginal revenue is equal to marginal cost in order to get our solution. Okay. So so now we have this general expression, and I'll just put some dots there and move it over. So the total revenue of firm one is going to be equal to the price that firm one charges for its product times the quantity that firm one produces. And the price is going to come from here, which is our demand function, right? And so I'll just go ahead and substitute that expression in. And so there are a lot of different ways to do this, but again, to just try to be as explicit as possible, I'll go ahead and distribute the Q1 over the term in parentheses. And the important thing to recognize is you end up with this expression, which is Q1 squared, because that's going to be important. And I'm going to move things around just a little bit by putting the expression P, Q2, Q1 in the middle. And I'm only doing that because when you go ahead and take the derivative, or again, if you want to just memorize this as a formula, that's fine. But all that's going to be left is this bit here in the beginning. I'm going to put that, I guess, in square braces so you don't get it confused with the parentheses from before. But you're going to end up with a linear marginal revenue function. And the intercept for that marginal revenue function is going to be this term that's in square braces, plus, and if you remember anything from your calculus class, you go ahead and you use this power rule. And that means if you're dealing with an expression with an exponent, you take the exponent and you multiply it by the coefficient, and then drop the exponent by 1. So obviously this is Q1, but anything raised to 1 power is just itself. So we leave it like that. So we have the marginal revenue expression. And then in all the problems that we're going to see, we'll already be given the marginal cost for the firm. And again, I don't know if this is really clear or not, but this profit maximization problem, if you were to work through it, what we're doing is we're just looking for a flat spot on the profit function, which is going to occur at the peak of the profit function. And so that ends up being the solution, is if I take the derivative of the profit function, which is the total revenue minus the total cost, and set it equal to 0, which means I'm looking for the flat spot, then I'll get marginal revenue is equal to marginal cost. And that's where ultimately this expression comes from. The reason why when firms are maximizing their profits, they set marginal revenue equal to marginal cost is because that's where the peak of their profit function is. Okay, so continuing on, so we have an expression for marginal cost, and our expression for marginal cost is normally going to be also, you know, a simple linear function. And in all of the problems that we have on the Cournot homework, it's just going to be, and I'll be a little bit more explicit by saying it's C1 times Q1 is the form where there's this coefficient in front. Okay. And so then we can finish finding the reaction function for firm one by finding what value of Q1 is associated with setting marginal revenue for firm one equal to marginal cost of firm one. So let's say MR1 is equal to MC1. And now we've constructed everything and we have it. And so we're just doing this. Okay. And then when we find Q1, it'll be some generalized function of Q2, and that'll be our reaction function. Okay, that's our solution. And we can follow these exact same steps for firm two. And I'll try to move everything to make a little bit more room. Okay. And I'm going to add a little bit more notation here, because obviously the function for firm one's reaction function is going to be different from the form of the reaction function for firm two. And so the Nash equilibrium then is where I look for, and you have to do it for both of them, but I'm looking for you know, a solution of Q1 and Q2 that balances the two reaction functions. So I'll call it Q1 and E for the Nash equilibrium for firm one. And the way I get the Nash equilibrium for firm one, and then I'll put the Q2 and E, the Nash equilibrium for firm two, is I just go ahead. And I do that. I substitute the reaction function of firm two into the reaction function for firm one. And then I would have one expression, and maybe I can do something down here at the bottom in red, right? So I'll have Q1 NE F1 And so if I substitute in for Q2, I'll end up with F2 Q1 NE. Okay. So that shows me how I end up with one expression in Q1, and the value of Q1 that satisfies that expression is a Nash equilibrium for Q1. And then once I have that, I can just use the reaction function for firm 2 and get Q2 NE. Okay. So are there any questions about that? Let me ask Emily. How are you doing, Emily?
I'm good. How are you?
I'm fine. I'm fine. Are you all ready for Turkey Day?
Yeah, kind of.
Okay. So you got a pretty bad echo, so you might want to turn down me when I don't know if you have headphones or not, but anyway. So does this explanation make sense to you in terms of how the Cournot is constructed, Cournot equilibrium is constructed?
Yeah, it does.
Okay, good. All right. So now we want to go ahead and compare the Stackleberg. So in the case of Stackleberg, what you're going to have, and I'll try to move things around. So again, I have more room. So, and this is the leader follower model. And so in the case of Stackleberg, in almost all the problems that we have, I think all the problems we have, we're going to assume that firm 1 is the leader. Okay. And so what it means for firm 1 to be the leader is that firm 1 knows the reaction function of firm 2. Okay. So firm 1 is going to go ahead and I'll start down here because everything else is the same. Is that when and so I want to be clear about one thing, and that is that the reaction function for firm 2, right, is constructed exactly the same way you would for the Cournot example. So I'm going to go ahead and circle this part. Try to, or oval it, right? So but the difference is that once you're talking about what the leader is going to do, the leader is going to maximize their profit in the way that they would have before. But in the total revenue portion of it, they're going to take into consideration that the output that they produce is going to influence the output that firm 2 produces in a known way. And so they do that through the reaction function. So for example, they can forecast what the influence of their output decision will be on the final price of the product, because they would know something. For example, if I produce 3 units, firm 2 is going to produce 1 unit. So there'll be a total of 4 units in the market. They know the demand function, they can figure out the price. So it's that kind of logic that that makes the profit maximization problem of the leader different, and in an important way. It's different because ultimately the profit that firm 1 as leader makes depends only on the output that firm 1 produces. And that way they're a lot more like a monopolist. The difference is that they have kind of this side channel, right, which is the output decisions of firm 2, as firm 2 reacts in a predictable way to the output decisions of firm 1, and firm 1 knows that. So we're still going to be doing the total revenue minus the total cost of firm 1, and ultimately, right, we're still going to be employing the solution that we did before, which is you're going to find the output level where the marginal revenue of firm 1 is equal to the marginal cost of firm 1. The difference here is that when we construct the marginal revenue of firm 1, we're going to introduce this new bit of information. So that is the reaction function of firm 2. So here's the total revenue of firm 1 is still going to just be the price of the product times the quantity that firm 1 produces. And again, we're focusing on total revenue because we're going to focus on marginal revenue, right? And now when we introduce the price, and I'll go ahead and draw a little arrow to call your attention. So probably it's this version of the demand function that's the easiest place to begin working. So I'm gonna just grab this. Okay. But this Q2 is coming from the reaction function here. Okay. And so maybe, well, yeah, they don't really let me draw a squiggly arrow. So I'm just going to draw it like that way. And so notice now I'm using the explicit form of the reaction function. I'll just put a times there, and I'll change these to square brackets so we don't get the parentheses mixed up. Okay. So because we introduced the reaction function of firm 2 into the demand equation, now firm 1 in the leader follower model as the leader has a total revenue that depends only on the output of firm one. Can you see that, Emily? There are only Q1s here.
Yeah, I can see it.
Yeah. So then we can go ahead and calculate the marginal revenue for firm one. And again, just remember that it's the derivative of the total revenue function with respect to the output of firm one. And then you'll end up with an expression, and then you can find the solution, because we know the marginal cost of firm one. So we set marginal revenue of firm one equal to the marginal cost of firm one, and that's the solution to this is the liters output. Okay, and then again, what we do to find the follower's output, and we could call this Q1 Stackleberg, and to find the follower's output, we just use the Cournot reaction function again, but I'm going to label it stack. It's going to be F2 Q1 stack. Okay. So that's the relationship between Cournot and Stackleberg. Does anybody have any questions for me about any of that? No questions. Okay. Well, let's go ahead and work on a problem together then. This is number 8 on the homework. Okay. So I will I can't really do these side by side. I was trying to see if there's a way I could fit it all on one screen. I think there is a way. And what I'll do is I'll put it here. It'll overlap a little bit. But you'll have all the numbers on the same screen. And I'll put it in pink. Okay. So you all have all of the information. So I'll give you about 10 minutes to go ahead and begin working on this. And then I'll call on you to help with it. So Alex, you here this morning? Alex Ortega.
Yeah, I'm here.
Okay. And Alexander Galvan, you here? Okay, Alexander Galvan seems like he's been quiet this morning. So Alex Ortega, I'll start with Alex Ortega and Emily when we get back in about 10 minutes, okay? Oh, you're here, Alexander Galvan. Okay, is your mic not working? Okay, yeah, because it's a little bit hard, but to chat then. But I can still I can still ask you about numbers, Alexander Galvan. So we'll do Alex, Emily when we get back. I have it as being 9:13. So we'll come back at 9:25 and we'll work through the solution to this in the last 20 minutes of class. Okay. Do you guys have any questions for me for getting started? Okay. Seeing no questions. Okay, see you in 10 minutes.